Hi, it's Mr. Kane here with a video on our types of energy, in particular potential energy, and we're going to look at how we can go about using that equation and rearranging that equation. So here's a typical student, plenty of potential, but we need to get them moving. So with a brick to the head might help. Can't do that, sorry. We better move on and start looking at our potential energy equation. So here it is. Figuring out how much potential energy you gain by gaining some height against gravity. Mass times the gravity constant times height that you've gained. So let's use that. Let's put it into an example. We're going to use stair climbing because it's one that we often use in science to figure out how much energy you've gained and kinetic energy and power and so forth. So here's an example. A young lady climbing some stairs. I've guesstimated she's weighed about 60 kilos and the stairs are 3 meters tall. How much potential energy does she gain when she goes up the stairs? So we've got our equation. All we've got to do is plug in the numbers. 60 kilos times 9.8 being the gravitational field strength or acceleration due to gravity, and 3 being the vertical height she's gained. Chug through the maths. The answer comes out as 1764. That's simply a number. Finish it off by adding the units, joules. She's gained 1,764 joules by climbing these stairs. That's all fine, but what happens if you're asked to find the mass or the height? You've got to rearrange this equation. And we're going to use the triangular sort of tricks that we used before, or you may have met elsewhere. And we've got a couple of options here. We've got this one, or that one. So what's the story with that one? Suddenly we've got an F there. Where'd that come from? So let's look at this. We met this equation earlier on. Force is mass times acceleration. Well, we've got a mass number and we've got acceleration due to gravity. So it's just vertical. So our A, we can swap out and turn it into a G. Force equals mass times the gravity constant times height. So mg is F, so E equals Fh. Let's put it to use. So how much height did our woman gain climbing these stairs? So we've got to go through and look at, okay, F equals mg. That was our 60 kilos times 9.8, so 588 newtons. That's our F number. We're trying to find H, so we do our cover, what we were asked to find, rearrange the equation. So H equals E divided by F. Plug in our numbers, 1764 divided by 588. Chug through the mass, spits out the answer 3. That's not the answer, that's just a number. It's an answer when you add the units. She's gained 3 meters of height. Let's try using this version. This is actually my preferred version. Because it allows you to find the mass as well without having to rearrange and worry about F and that sort of carry on. I think it's simpler and easier. Let's use the same example. So we cover up what we're trying to find. That's the H. Rearrange the equation. So now we've got H is E divided by mg. Plug through the maths. 1764 divided by 60 times 98. So we chug through the maths to get that. Numbers 3. And add the units, we get the answer of 3 meters. Let's try finding mass. But G, never have to worry about finding that. It's always a constant, it's always given, either 9.8. Sometimes they round it to 10. Do check. Look out for it on the books or the test papers you're using. Typically 9.8, but sometimes 10. Just do watch out for it. So let's find the mass. She's climbed 3 meters of stairs. We know she's gained 1764 joules of energy. Let's use the same method as before. So we cover up what we're trying to find. Rearrange our equation. Mass equals energy divided by G times H. Plug in our numbers. There we go. Chug through our maths. It spits out the number 60. Finish it off by adding the units, so her mass is 60 kilos. So next time you're chugging up an endless flight of stairs, think about how much potential energy you're gaining. Or you can rearrange the equation and find out the height if you know the energy and the mass. So that's that. Thank you very much for watching. Now go and practice.